There you go. So, lesson 1 for online learning, lines that intersect circles. So here's your vocabulary that you're going to want to put into your notebook. And I recommend making notes for all these. So when you're doing your IXLs or you're taking your take-home test, you have something to refer to instead of having to re-watch a video over and over again. So here's some vocabulary. Interior of a circle, the sets of all points inside the circle. Exterior of a circle, set of all points outside the circle. A chord, a segment whose endpoints lie on the circle, which you can see in green in the picture below. Secant, a line that intersects a circle at 2 points, but it goes completely through, so it's a line that's never ending. A tangent, a line in the same plane as a circle that intersects it at exactly 1 point. You'll see the black line in the picture. The point of tangency is the point where the tangent line intersects the circle, so that black dot you see. Now, you've actually dealt with chords in the past. You've dealt with a diameter. A diameter is a special chord that passes through the center of the circle. A few more definitions. Congruent circles are 2 or more circles that have the same radii. So our radius here is 2 and 2, therefore making them congruent circles. Concentric circles are coplanar circles with the same center. So the centers are at the same location, but one's usually bigger or smaller. Tangent circles are 2 coplanar circles that intersect at a single point. So like at point F in the picture below. All right, so fun facts about tangent lines and circles. If there is a tangent line to a circle, then there is a radius that is perpendicular to it. So you have the red tangent line, you have the blue radius, and where they intersect at H, that creates a 90-degree angle. If there is a radius perpendicular to a line at a point on the circle, then the line is tangent to the circle. So our last little fun fact about tangent lines and circles: if 2 segments are tangent to a circle from the same external point, then the 2 segments are congruent. As an example, if HI and JI are tangents of circle A, then segment HI is congruent to JI. So these 2 segments right here would be congruent to each other. All right, so now let's tackle problem 1. It says find the length of CF. Well, this is trying to get us to apply the idea that the radius, which is AC, is perpendicular to the tangent line CF, making this 90-degree angle. Therefore, if you want to find CS, you really have a right triangle. So we use the Pythagorean theorem to figure out what CF is. So we have our a squared plus b squared equals c squared. We'll have 6 be our a squared. We'll let CF be our b squared. And our c is always our hypotenuse, which is opposite of the 90-degree angle. So we'll have c being 15 for us. So we go ahead and do the calculations. We got 225, we got the b squared, and we got 36. We want to get b squared by itself, so we minus the 36 over. We get 189. We want to square root both sides, and we're going to get a decimal. That is roughly 13.7. We're going to round to the nearest tenth. And we have found CF. Okay, problem 2. Find angle A, given CF is a tangent line. So once again, since we know that CF is a tangent line, we know angle C is 90 degrees. And we know in a triangle, all 3 angles should sum up to 180. So 180 minus 37 minus 90 would give us 53. So we'll know that angle A is 53 degrees. All right, so for problem 3, they want us to find angle F and the segment AF. Now the green X and the purple X are going to be two different values. This is two separate problems I just merged into one to try to save some time. So we're going to use the Pythagorean theorem to find the segment. So a squared plus b squared equals c squared. We got 8 plus x minus 2 equals x, and they're all getting squared from the Pythagorean theorem. We're going to have 8 squared, which is 64. The x minus 2, we're going to go back to Algebra 1 and do the box or foiling, whatever you were taught. So x times x is x squared, x times negative 2 is negative 2x, negative 2 times x is negative 2x, and negative 2 times negative 2 is positive 4. Then we're going to go ahead and combine our like terms here, and we will end up with x squared minus 4x plus 4. So plus x squared minus 4x plus 4 equals x squared. All right, so from here, we're going to go ahead and combine any like terms we have. So we have 64 and 4. This is going to give us 68. From there, we want to get x squared by itself, so we're going to subtract it to both sides. And that's going to have the x squares cancel out, giving us negative 4x plus 68 equals 0. I'm going to go ahead and add the 4x over to the other side, making it positive. So we have 68 equals 4x divided by 4. So we're going to get 68 divided by 4 is 17. Now that we know what x is for the green x in the problem, we can figure out what AF is. AF is 17. Okay, now we want to go ahead and find out what the measure of angle F is. So we want to figure out what x is. Now, once again, we have ourselves AC being the radius and CF being a tangent line, which would make angle C be 90. And the angle should add up to 180. So we have 90 plus x minus 4, which is angle A, plus angle F, which is x, equals 180. And we go ahead and solve the problem. So 90 minus 4 is going to give us 86 plus the x gives us 2x equals 180. We want to get the x by itself, so we're going to minus the 86. So 180 minus 86 is going to give us 94. We're going to divide both sides by 2. And so 94 divided by 2 is 47 degrees. That is our angle F. All right, so problem 4, find the measure of angle A. Once again, this is making sure you understand your theorems, that FD and ED are both tangent lines. Therefore, angle F and angle E are both 90 degrees because a tangent line is perpendicular to the radius of a circle. And we have ourselves a quadrilateral. And we should know that a quadrilateral has 360 degrees. So we know angle F plus angle E plus angle D plus angle A should add up to 360. Well, we know F is 90, we know E is 90, we know D is 40, and we're looking essentially for angle A. So 90 plus 40 gives us 220 plus angle A equals 360. subtract the 220 from 360, we get angle A being 140. Okay, it wants us to find angle A. Once again, FD and ED are both tangent lines, making 90-degree angles for angle F and angle E. Once again, we want to add this up and set equal to 360. So we got 90 plus 90 plus 2x plus 30 plus 3x equals 360. Going to go ahead and combine the like terms we have. So 90 plus 90 plus 30 is 210. And then 2x plus 3x is 5x. We want to get x by itself by subtracting 210. So we're going to have 150. Divide both sides by 5. We're going to get 30 for our x. Now it wants to know what the measure of angle A is, so we're going to substitute in to the expression 2x plus 30. Going to plug in 30 in for x. We're going to go ahead and do a little math. So 2 times 30 is 60. 60 plus 30 is 90. So angle A is 90 degrees. All right, so problem 6. FD and ED are both tangent lines, and they are connecting to the same external point, which means that the two tangent lines are actually congruent to each other. So we just set the two problems equal to each other, two expressions, and solve for x. So we can subtract the x over here, and 2x take away x is x, add your 1 over, so you have 4, and now you know what x is, you can find df by substituting in. So df is equal to x plus 3, plug the 4 in, so 4 plus 3 is 7. All right, is CF a tangent line? So in this question, what you're really asking is, do you know if this triangle is a right triangle? If it's a right triangle, then you'll know that angle C is 90 degrees. To figure that out, we're going to go ahead and use our formulas from earlier in the year, where we had C squared equals A squared plus B squared, basically using the Pythagorean theorem. When we plug it in, if the left side and the right side equal the same thing, then we know we have ourselves a right triangle. Therefore, then we'll know that angle C is 90 degrees. So C should be 5 because it's our hypotenuse. I'm going to make A 3. I'm going to make CF be our B. So we're going to get 25, 9, and 16. 9 plus 16 is 25. So yes, we have triangle ABC is a right triangle. Therefore, we know angle C is 90 degrees. So yes, CF is a tangent line.